The person who invented the ceiling fan was really a genius. Most of us must have used it when we were children. Do you know how it works? If we open the fan, we can see that the overall structure is not complicated. First, we can see an iron piece with many holes punched out. Then we combine many pieces together, which form the stator core inside the fan. Then we wrap the winding coil around the stator. In the hole in the middle, we need to install a spindle and pass the end lead of the winding through the middle of the spindle. The whole structure is the stator of the ceiling fan. Next, let's take a look at the rotor part. This is the bottom shell part. It looks slightly concave. There is a round hole in the middle. A bearing is installed in this hole. The upper shell part has the same shape as the bottom shell, and there is also a bearing in the hole in the middle. This is the core part of the rotor. The rotor coil is stuck in these teeth of the upper shell. Next, we need to assemble the upper shell and the bottom shell to make it a complete rotor. Don't forget to put the mirror in. We use the fixing screws to fasten them together so that the ceiling fan head is assembled, but this alone can't work. To make the ceiling fan work smoothly, we install this capacitor on the main shaft, and then we install the fan blades on it. The ceiling fan is now assembled. How does it work? It's actually very simple. First, the electric coil we just assembled will generate a magnetic field after being energized. When combined with the rotor, a magnetic motor is formed to generate rotational torque through electromagnetic induction, and then drive the fan blades to rotate. Did you notice that there is a capacitor on the ceiling fan, and what is its function? I believe you must have encountered such a situation. When the fan is turned on, the fan speed becomes slower and slower, or even stops. In this case, the capacitor is most likely defective. After replacing the capacitor, it will restore the normal function of the fan. The capacitor in the ceiling fan mainly helps the motor start and operate. This is because the starting energy required by the motor is higher than the electric energy required for its own operation. When the fan starts, the capacitor can provide a certain current to the motor, so that the motor reaches the starting speed. The capacitor will continue to provide power to the motor to ensure the stable operation of the motor. When the capacitor is used in conjunction with the motor, a phase difference can be generated. Under the influence of this difference, the motor can run more smoothly. A smaller swing can reduce the power loss of the motor and improve the efficiency of the motor. At the same time, the capacitor in the ceiling fan can also effectively extend the service life of the motor. When the fan starts, due to the effect of the capacitor, the motor can start at a lower voltage, reducing the load on the motor when starting. This will reduce the risk of damage and burnout caused by excessive starting current. In addition, the capacitor can also prevent excessive vibration of the motor, making the motor more stable during use, thereby increasing the life of the motor. If you enjoy this video, then hit like and follow for more.